received a inquiry from a client about installing a lock set onto a 3-inch thick door. This door is basically a gate. It's a very nice looking gate, but it's in essence a gate between a street and the approach to either a single family home, but most probably a multi-tenant dwelling, a 3-flat, whatever the case might be. And the client says his email was that he just simply couldn't understand why it was so hard to find a lock for a 3-inch thick door. And it's not hard to find them. It's just, can you find one that's going to do the job and do so reasonably regarding the cost, or at least what the perceived cost is? So the client he basically said, it's hard to believe it's so hard to find one, but what he really meant was, well, I can find them, but I'm not going to pay that kind of money for one, is really what he meant. So let's go over the project, let's go over the proposed solutions, and then let's finally get to what the client did in terms of how the problem was solved. And I'm creating this video so that you can take a look at this solution. Even though I've discussed it in the past in other videos, you'll now be able to see the solution. So let's move on. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. So the project is a gate that's 3-inch thick. There's an electric strike. The need is to have access control over the opening. The existing gate is prepped for a lock set, in the sense that it was prepped to receive a lock set, and what was installed was a deadbolt. So originally, it was a gate with a deadbolt, and you could simply lock it and unlock it. It's double cylinder so that no one could reach over and throw the thumb turn and just enter. Client wanted to add access control, and that's where it starts to get interesting. Access control means you've got some credential that's not a mechanical key, and you're going to get in. Or someone is permitting access remotely. The term buzz someone in would very much apply to this. The term buzz means that what it actually means behind all of that is you have generally an electric strike. And the electric strike, when someone activates the electric strike, you hear a buzzing sound. Well, what that buzzing actually is, it's telling us that it's wired with AC voltage, and that the strike is always unpowered, or there's no power going to the strike, and the strike is always in the locked condition. So when you buzz someone in, what you're doing is you're closing the circuit, allowing AC voltage to cycle through the circuit, powering the electric strike, meaning unlocking it so that you can just take the door and push it open, because now the keeper that's holding the latch bolt is now free, allowing the keeper will then rotate, allowing the latch to come right out. DC voltage doesn't buzz. So if you hear buzzing, you know it's AC voltage. Why is that important? Why is that important? It's important if you're troubleshooting the circuit to know what voltage it is. So if you ever hear something buzzing, you can say, you know a couple of things about it. First of all, it's AC voltage. Second of all, it's a fail-secure strike. So you'll always know that, meaning the strike, when it's not powered, is locked, because if it was the type of strike that required power to lock, which is called fail-safe, you would hear buzzing continuously. If you ever encounter a strike that's in the unlocked position, it is fail-safe and there's no power to it, or it's fail-secure and there's power going to it. Anyway, let's move on. So the client had a deadbolt, wanted to add access control. Well, the regular old deadbolt isn't going to provide access control, in the sense that when the gate goes to close, and obviously having this gate self-closing is something that would be necessary, because you need to let the pizza guy in, and when the pizza guy opens the door to leave, it's going to close behind him. You want that secured. So a deadbolt's not going to work really well, because that bolt, when it's thrown, is just going to come and hit the face of the jamb. It's not going to re-latch or auto-latch or self-latch. So you're going to need to get rid of the bolt and add a latch. And an elegant way to add a latch is to simply have a lock set. And the type of lock that you want for this application would generally be a storeroom lock. And what that means is the outside is always locked, meaning any operable trim is always rigid, and you always need a key to get in. However, the egress side, the side that you're exiting from, It's always unlocked. There's no key, there's no thumb turn, you can always get out. What's important about this lock is you can always exit. What's important about this lock, you always need credentials to get in, either a mechanical key or you need to be buzzed in. And third, you can never leave a storeroom lock in the unlocked condition. Now, we'll take note later when I show you some photographs. The client has the wrong function of lock installed. If it doesn't bother him, it doesn't bother me, but the function that's there is what would likely be an office function where there's a thumb turn that you can unlock. So someone could leave that gate unlocked and be able to just come back in anytime. I would imagine the people doing that are ownership. But if someone knew to reach over and to flip that, you'd be able to easily get in. So you would not want that. However, if you can just reach in, you'd be able to also just unlock the unit. And there are products that go a long way to preventing access to the inside trim in those exact situations. If you have wrought iron that you can just reach your hand through and turn the knob or the lever, that's not much security. But there are products to help thwart that. So adding access control is the point. The client wanted to take what the client assumed was the most direct path. Just get a lock for a 3-inch thick door. Okay, it's not difficult. It's actually easy. But when you get past 2-inch or 2 1/4, the entire world of the availability of what you can put onto a door absolutely changes. So I said earlier, a way to do it would be to put something latching on there, what we call a lock. That would either be tubular or cylindrical or mortise. These are just construction platforms of lock sets. They're different types of locks in terms of how they're manufactured, the parts that go into them. They all do the same thing. They lock the door. You could also, the client could also have put a deadbolt on there, but it's not a deadbolt, it's a dead latch. There's a couple of manufacturers I can think of that make double cylinder locks. They look like deadbolts, except that their latch is a slam latch. Schlage makes one, and Marx makes one. They can do 3-inch. You're going to need longer parts. Sometimes those parts are easy, and sometimes they're not. Getting out to 3-inch shouldn't be a problem. But when you do a lock like that for a thicker door, and don't quote me, I'd have to actually check the manufacturer's capability of going to 3-inch. You're always going to need longer screws and longer tail pieces. Okay? And that goes for the thought consideration of what you need to stretch a lock out in terms of different parts absolutely applies to the tubular, the cylindrical, and the mortise lock as well, because parts need to be changed or manufactured in such a way. Moving forward, it's awfully important to know that when we look at the photographs, which we will in a moment, the lock was centered in the door. If you've got a 3-inch thick door, you can put the lock right in the center. You could bias it towards one side as well, and that really affects what you're going to need to supply someone. If you have a lock that's centered, then what you have to do is build the chassis of the lock and any parts that need to communicate right in the center of the thickness. But if it's offset to the inside or biased or offset to the outside, you need to adjust all of those parts. Some parts might be standard, whereas the others are extra long because you're not going to the center, you're going further away. That's going to relate to not only spindles and tail pieces and screws, but it's also going to apply to the lip length on a strike plate. If you have an in-swing door, and the lock is centered and it's thicker than usual, it's a 3-inch thick door, you'll need a longer lip on that strike, because otherwise the latch bolt's going to come and it's going to make premature contact with the casing. And you'll see in the photographs how the client got around that. And it turns out that the electric strike they have, there are lip extensions for those. He could have easily, the client isn't a hardware person and they're not aware of other items that would solve the problem, like a self-closing device, like lip extensions, stainless steel hinges, which I'll point out to you. But you need to think about the length of the lip as well. Some manufacturers' catalogs just have a parts breakdown of, here's what you need. If your door is X thick, you need this and this. You do need this, you don't need this, or you need both, or you don't need that and you do need this. Spindles, mounting screws, strikes, and it all depends on where in the thickness that lock is centered. Is it centered or is it not centered? And if it's not centered, to what side has it been biased over? And what is that dimension from the face of the door to the center line of the lock, and then from the face of the door to the center line of the lock? Okay, you'll always need to determine that. Other manufacturers don't make it so easy, and I'm thinking of a couple of them. You've got to email your outside sales rep to create a special application request. You know who I'm talking about, to be sent into technical support. My logic is just build the table. If you know that you're doing a mortise lock or a cylindrical lock for X thickness, you know what parts you're going to use. Just publish it so we know how to price it. So my approach to the client, what did I provide them? The request was, I need access control. I've already got the electric strike. I need a lock for a 3-inch thick door. What do you have for me? Let's talk about what do you have for me. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. So in this client's application, I discussed with the client the cost of lock sets for unusually, extraordinarily thick doors. You are in the several hundreds of dollars, and frankly nowadays you're over $1,000 for a lock for a custom thickness door. They only make extended locks for 3-inch in the grade 1 heavy duty material, so you're already looking at a lock that's several $100s. Then when you look at the parts that go into those locks when they're extended, everything is customized. They're literally, it's almost as if they're commissioning a lock for that application. So when you look at this extremely unusual lock that's been built for an unusual application, you see all these parts that don't look like a normal lock, although they do, they're just stretched. And then you can start to realize, this is really expensive. So it's a grade 1 cylindrical lock is option A. Option B is a mortise lock. Mortise locks are nice because it's really just parts that you need. Maybe you'll need a spindle, you'll need mounting screws, you may need a strike with an extended lip, which all boils down to where the lock is positioned in the door thickness. But again, that was over $1,000, and the client said, I don't want to spend $1,000 on this. Okay, and I then learned that I think what I learned is that the electric strike was existing, and that they went ahead and installed the electric. That's probably what it was. They installed the electric strike based on the fact that the deadbolt that was there was centered in the door, and then the client proceeded to search for a lock for a 3-inch thick door, and that's when he stumbled into it. I provided the idea of an electromagnetic gate lock, a magnet meant for an exterior application. They exist. And for a lot less money than the cost of an extended custom lock set. Not a lot less, but noticeably less, 30-40% less. So the client could have had access control, keypad, card reader, remote control over it, absolutely. And I personally like the solution of the gate lock because it does give the client the ability to have access control over the opening in such a way that doesn't require, an unusual lock, even though a thicker door lock is more elegant than a big, large electromagnet installed on everything. And then the other additional components I would have suggested would have been just a couple of dummy knobs that could have been easily through-bolted through the door. And then also I probably would have added an annunciator, because that electromag, that gate magnet, is always going to be powered, meaning it's fail-safe. So in the absence of power, when the power is cut or the circuit opened, it will release the magnet, allowing you to enter. Well, how do you know when it's time? You're not going to hear a clicking sound or a buzzing sound. I would have added a single pole double throw switch, so that when power was opened to that circuit, I would have then closed the power through the annunciator so that you'd have a buzzing sound. And then that door position switch could basically have turned off the buzzing sound when the door came back closed. A door position switch is when the two pieces, one in the frame and one in the door, are together, the circuit's either open or closed. But when you open the door, that circuit is in the opposite state. So if the power is open, meaning there's no power when the door is closed, you introduce power into the circuit and you open the door, that's going to change the state of the electrical configuration. So you can see that my solution was getting more cumbersome, I suppose. And, well, I sent the client the electromagnetic lock, and he responded. Well, the response was, yeah, I appreciate the solution, but it's just not what I want. And following back up with the client responded with, my apologies for not getting back to you sooner. Our solution to the doorknob problem of a 3-inch thick gate was to recess a standard doorknob into the existing knob hole. Not the most elegant solution, but certainly much more cost-effective and worked out great. I don't know why we did not think of that solution much sooner in the process. I can send you a photo if you're interested. So I obviously was thinking to myself, I would just recess that and put a standard lock on. But that wasn't the outline that I was given. I would have suggested to the client, once the client reviewed the solution for the gate magnet, I would have said, well, here's a way to do it. You can do it this way. Make a standard lock fit on a thicker door. And let's talk about now exactly how that's done. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. It means a lot. It takes a lot of work to create these videos in the sense that it's time taken away from doing other things. However, the advantage for me personally of creating these videos is the fact that it does allow myself to either learn about something new, to reacquaint myself with something, or to reinforce what I believe that I already know. Any comments that you might leave down below would be greatly appreciated. Thank you. So in these instances where you want to try to accomplish this, and it'll be more obvious when I show you the photographs, what I would do is, in a gate application, I'd probably just want a knob. I wouldn't want a lever. I don't want to give people on the sidewalk something to grab onto or lean onto. Just a knob. People tend to not touch those as much. In a storeroom configuration, unlocked on the inside, you can always exit, always needing a key or access control or credentials or permission to get in. The point of the mechanical key is, should the power go out and your electric strike is not working at all, or the intercom go out, or there's a power outage, you can always come in with your mechanical key. Okay. So what I would do in a case like this, where the hole was already existing, and it is, I would needed to have made the hole a greater diameter and to a certain depth. The greater diameter is for the outside diameter of the rose. Assuming you have a round rosette underneath your trim, that will have a particular diameter. Let's say 2 13/16, something like that, or 3 1/2, or whatever it is. I would have added 1/8 of an inch to that dimension, and I would have routed with a router that diameter hole to a particular depth. How I would have done that would have been, I would have created a wooden template to the proper size. I would have clamped that to the door, and I would have routed with a plunge router this larger diameter to a particular depth. That particular depth is, what is the door thickness minus the door thickness that the lock is intended for, divided by 2. That's the depth I would have done that on each side of the door. Each side, because as you'll see in the photographs, that lock prep, the latch bolt prep, is centered in the thickness of the door. I don't know how the client actually re-prepped their door. It looks like they used a hole saw, which it's possible to do that, but you need some way to take a hole saw and guide it through a hole that's already drilled. There are pieces of hardware that allow you to do that. We actually sell them. What you can end up doing is taking that larger diameter hole saw, and where the arbor bit is through there. You can add a conical shaped device that will rest right onto your 2 1/8 inch hole, because the arbor has nothing to bite into, the arbor bit, which is generally a 1/4 inch, I guess, I think. And then you can bite into your 3-inch hole saw, or you know, whatever diameter hole saw that the client needed for the diameter of the rosette. You could have drilled deep to a particular depth with the hole saw, then got in there and reworked and chiseled out all what was left, but a router would be far more elegant in order to do that. And however the client got there, that's how they got there. And that's what the client did. Let's switch to the screen view and let's look at the photographs. Regarding the links to ads that you might see in this video, we do apologize for any interruption to a smooth viewing experience, and hopefully the ads that are being presented to you are related to the base product. And if there is something, feel free to click on those and perhaps consider taking a look at what that other advertiser is promoting. Let's get back to the video. So this is the electromagnet that I suggested to the client. They could have got this installed. You would have had to have used a Z bracket or some means by which to make something work. You would have had to have made an accommodation to get it to work. But you do see them every once in a while. There's no doubt. And this is basically what it would have looked like. Okay, Z bracket to allow you to get the magnet installed onto the gate post. Your armature would have been applied to the face of the gate. So yeah, it would have worked, and it would have been less money material cost wise to make all this work, but it would have been far less elegant. Now let's take a look at photographs. So here is the client's strike. The client sent this to me saying, yep, we installed that electric strike and then found out that locating a lock was a problem. Okay. This is the edge of the door. This is 3-inch. That prep is right in the center of the door. What's interesting is, I think what this... I really don't know what this is. That's obviously a piece of steel reinforcement that's there. You know, it looks like it's a wood door, but I don't absolutely know the construction. And here is the 2 1/8 inch hole that's through the door. And what was there originally was, I don't actually know what was installed originally on this when it was a non-electric strike installation. And here is what the client ended up doing. This is the finished product from the client. And that's exactly what I was describing. They took the diameter of this probably Schlage F51 Levon keyed lock set, and it does look like a hole saw, drill that to a particular depth, and then simply install that lock onto this gate. This is the accommodation they made for the fact that you don't have a lip extension. So the latch bolt's going to end up hitting the casing before it hits the strike. Well, they've cut that area out elegantly and solves the problem. So there we go. Now the client's got a full functioning solution. And absolutely. So the moral of the story is, I would, if you're running into the same scenario as this client, absolutely consider this as an option. I have suggested this to countless people over the years, and it does work. Now, the issue with that is, obviously your clearance from the back of the lever is substantially reduced. This return here may hit this if it were to rotate far enough, or if this was a knob, you now can't get your hand behind the knob very well. And so I would have taken the door with its hole, and I would have taken a piece of wood, poplar, whatever the case is. I would have clamped it down to the door, and I would have then created a bigger hole in it, because this piece of wood now, it could be whatever size you want. Where you're going to place the hole is going to be dependent on well, the back set. I would make it so that I flushed the template to the edge of the door so that I had a center line established right through here. And then you're going to take your router, and with your router guide, it's just going to go through this template to create the larger diameter hole. You're going to go from that to that. You don't have to worry about getting that arbor bit biting into something that doesn't exist. And that tool that I was mentioning earlier can be seen here. The GKL HS1, this is exactly how that works, and this will work for re-drilling a larger hole into a hole that already has a hole drilled into it. A hole alignment guide enables you to rebore an existing 1.5" and turn it into 2 1/8. So the concept would not have worked, this tool would not have worked for the client because it will take you from 1.5" to 2 1/8, but this concept would work. You'd have to create your tapered cone or some sort of block. Yeah, that's what it looks like. But it is a reasonably elegant solution in those cases. I would have routed that to the proper depth so that now I'm achieving this. I would have done that on both sides. And now I've got a hole that looks like that. That's my prep. Everything in here. That would have worked out really, really well. And I would have ultimately have had this. And this is basically what the client created. Now his lock sits right in here really well. And there that is. Moving back to the solution of lock types, cylindrical or mortise would be the answer. Mortise would not have worked for this because the door is already prepped. A cylindrical lock would have worked. The issue with that, though, well, let's discuss the issue with that, then wrap up this video. So the issue with a cylindrical lock is that many manufacturers no longer make grade 1 knob locks. You can do them in levers, but this would be perfect for a knob. I would not have chosen to do a lever prep on that as well. So it might be a challenge to find an extended door thickness knob lock set, is just the bottom line. So if you have any questions on how to come up with a solution for this, we can provide hardware solutions. They're never going to be inexpensive. It is true that a lot of customers, they just buy these unusually thick doors and think the rest is super simple. It's not. The locks have to change, the hinges have to change, the weather stripping possibly has to change. It all is impacted by the thickness of the door. So consider reaching out to your hardware supplier before ordering unusually thick doors, and it goes for thin doors as well. Thin doors are problematic because you can't fit hardware onto it, standard hardware like pivots and lock sets. So I bought these. I hear from clients, I imported these doors from Central America or Africa, and they're all 1.25 inches thick. That's a problem. Now you've got locks that won't fit. You've got hinges that are going to be really close to not fitting, etc. So if you have any questions on this or any other unusual door thickness lock requirement, please feel free to reach out to us. Thank you very much. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.